Hello student, let's try to see the derivation of degree of dissociation. This is the degree of dissociation. So how can we derive, student? Suppose I am having the molecule AN. So if you are deriving, this is going to be Na, right? So now suppose if the time is equal to 0, student, so y have taken the one molecule, so it is 0, product is 0. T is equal to T equilibrium you are taking, so it is the going to be n alpha, and it is going to be 1 minus alpha. So I is equal to, it is going to be what, student? After dissociation, particle after dissociation, divided by what, student? This is the association before dissociation. What is the before dissociation? How much you have taken, student? This is before, and total is, this is the after. So you put out the value, put out the 1 minus alpha plus n alpha upon what is there, 1. Here is the I. Now solve it out, student. Send the I this side. So I minus 1 is equal to n alpha minus alpha. So here is I minus 1, alpha can be common, n minus 1. So alpha is equal to what is there, student? I minus 1 upon n minus 1. So this is the degree of dissociation. Now the same way we have to calculate the degree of association. So how can you calculate degree of association? It is very simple, student, actually. So just opposite of this you write down the equation. So you have to take this time, student, n molecule of A. So this is the Na, so it is going to convert into An. This is there. Now what we can do, T is equal to, if suppose you have taken 0. So what you have to consider here is, student, that is, suppose I am taking this one 1. So it is going to be 0. And if you are taking T is equal to T equilibrium, so it is the 1 minus alpha, and it is going to be alpha by n. So I is equal to, this is going to be after what is there, association, divided by what is going to be there, before association. So it's going to be very simple. Now what you need to do, this is the before, and this total term is what is called stone after. Now you solve this one. So after what is there, 1 minus alpha plus alpha by n divided by 1, here is I. Put the I this side, I minus 1, this is equal to alpha by n minus alpha. So here you can take the common, student. Here it is going to be, dear student, in this case alpha we can take the common, student, there is no problem. So I minus 1, here if I will take the alpha by outside, alpha by 1 minus 1. So what we can do is, student, alpha is equal to I minus 1 divided by 1 upon n minus 1. So this is what is there, student, that is called alpha, student. So this is all about the answer, student. Thank you very much for watching. Okay, thank you.